This problem is based on the power. Okay. Now let us do the problem. Calculate the power output needed for a 950 kilogram car to climb a 2-degree slope at a constant 30 meters per second while encountering wind resistance and friction totaling 600 newtons. Explicitly show how you follow the steps in the problem solving strategies for energy. Okay. Now we know power is equal to rate of doing work or rate of transfer of the energy. Okay, because we know work and energy are related. As per the work energy theorem, work done is equal to change in energy. Okay, therefore, power is given by power is equal to rate of doing work. Rate of doing work, we express this as like this. Okay, work over time. So now we will write down the data. Mass is given as 950 kilograms, and then angle is given as 2 degrees, and then velocity is given as 30 meters per second, and then I am taking g as 9.8 meters per second square, and then force is given as 600 newtons. Okay, here this is the force of friction. Okay, now we have to find out the work. We know work is equal to force times displacement, F dot T. Okay, therefore power is equal to, power P is equal to F dot D times T. Okay, and we know D over T is equal to V. That means the displacement over a period of time gives velocity. So here D is equal to displacement and T is the time and V is the velocity. Okay, and now we have to find out the force. What is the force acting on the system? Now we see this is the angle theta. Theta is equal to 2 degrees. As this is 2 degrees, this is again 2 degrees. Okay, and then this is mg, and this is mg sine theta, opposite side to the angle. Okay, and then this is mg cos theta, and this is Fn. Okay, and then the object is climbing up. Therefore, the velocity is in this direction, and the friction resistive forces or dissipative forces are in the opposite direction. So F friction is equal to 600 newtons in the downward direction. So what are the total forces? F is equal to, F total is equal to mg sine theta plus F friction. Okay, and we will write like this. Power P is equal to F dot V. D by T is equal to V, so I will write F dot V. Now, I will input the values and then calculate. Okay. Mass is given as 950 kilograms and G is 9.8 meters per second square, and then sine 2 degrees plus 600 newtons times velocity is 30 meters per second. Okay. And when I calculate this one, I get 27,747.429 watts. That means, that implies P is equal to 27.7 kilowatts. Okay, so this is actually 27, I will write here 27,747.429 is equal to 27.7 into 10 to the power of 3 watts. Okay, and then 10 to the power of 3 watts is equal to 1 kilowatt. Therefore, this will become 27.7 kilowatts. And it is always better to convert the kilowatts into horsepower, because he is talking about the car. Better to convert the kilowatts into horsepower. We know 1 horsepower is equal to 745.69 watts. Okay, so what about this one, 27.7 kilowatts? How much horsepower it is. Let us calculate. This will give for us 36.7 horsepower. That means approximately 30. 1 second. This gives 36.7 horsepower. Okay, so that means 37 horsepower. Okay, 37 horsepower is the reasonable value for a car to climb 2-degree slope. Okay, hope this helps. Thank you. Bye bye.